Hmm. So in continuation to our antibiotic lectures in medicinal chemistry, now we are going to learn about aminoglycosides. So we know that what do you mean by glycosides and what do you mean by amino group. So these drugs are just like macrolides, have glycosidic linkage between non-glycoside and sugar portion. And the sugar portion consists of amino group as well as non-glycosidic groups consist of aminoglycosides. You can see most famous drugs like streptomycin, gentamicin, tobramycin, amikacin. It's also given for veterinary purpose. These drugs are given. Hmm? So let us see some of the characteristics and everything in next slide. The most famous drug and all thing. So, so as we told, aminoglycosides are named because the structure consists of amino group, consists of amino amino sugar, glycosidically linked to aminocyclitols. These are called as aminocyclitols. We will explain in coming slides. Please kindly remember. These are the non-sugar portions which are called as aminocyclitols. We will explain there. And the sugar molecules are present. Streptose and N-methyl glucosamine combined together gives the streptomycin, which is very good drug for the treatment of TB. The person who discovered this streptomycin was awarded with Nobel Prize because till that time there was no drug to conquer TB. So once after identification of streptomycin, then then the TB was able to treat it. So that's why they have given the name aminoglycosides. As they contain aminocyclitols, I told you, they consist of non-sugar portion, aminocyclitols. We can also call them as aminocyclitol antibiotics. You can also call them as aminocyclitol antibiotics. So these are broad spectrum antibiotics. However, gram negative, they effectively act. These drugs are bactericidal, even killing is present. At the same time, it is a broad spectrum antibiotic, but, but it mainly acts on gram-negative bacteria. Some of the notable bacteria which it can show action is E. coli, Pseudomonas aeruginosa, Neisseria gonorrhea, Chlamydia trichomatis, and Yersinia pestis. So these are some of the notable microorganisms which these drugs can act. Can act. Now, let us see. So what are the few examples? Anyhow, we will learn in classification and all those things. Some of the examples is streptomycin, amikacin, gentamicin. The first drug in all this is streptomycin, as I told you, and it is obtained from Streptomyces griseus. Griseus, earliest modern agent used in tuberculosis. This also I mentioned just now. And the person who discovered is Solomon Walkman. He is the one who discovered the streptomycin and effective drug in treatment of tuberculosis. And in 1952, he was credited by Nobel Prize in the field of medicine. Medicine. He was given Nobel Prize. That is the importance of this drug, streptomycin drugs. Now, let us see what are the things. Classification of drugs. Here, we can classify drugs based on the routes of administration. On next slide, we will classify the drugs based upon the chemistry also, but not much important. Let us see. Routes based on the routes of administration. Topical use. Topical use. That is for skin or eye or skin. Neomycin, framycin, which is also called as soframycin. Many people might be using this ointment for infections. Soframycin, gentamicin, gentamicin. Now, one more. Systemic use. Streptomycin, nitilamycin, gentamicin, tobramycin, and kenamycin. Kenamycin. These are for given by injections, IV route of administration we can give. Now, GIT infections. These drugs will not be absorbed into the systemic circulation, but it can treat the infections present in the GIT because these drugs, most of them are not absorbable. Though they have sugar portion, they're very good soluble in water, but cannot be absorbed because we learned that lipophilicity is important factor. So let us see. Neomycin, paramomycin, amikacin. These are used for treatment of GIT infections, especially bowel parasites, liver infections. They're very good drugs. They stay there, they kill the microorganisms, and also we learned that these are bactericidal drugs. Bactericidal drugs. So they stay there and kill them, but not absorbable. Not absorbable. Now you can see in the spelling, some drugs are having MYCIN, some drugs are having MICN. Based upon the source of their biological source, they have given the name. Drugs obtained from streptomyces end with suffix mycin. Drugs which obtained with microspora, they end with suffix mycin. MICIN. Spelling looks, whenever you pronounce, the pronunciation spelling is mycin. Both are same. Only thing is that you should remember whenever there is a spelling MYCIN, that means they are obtained from streptomyces. Whenever there is a spelling mycins, MI, then they are obtained from microspora. I also written in different color, which you can identify from here in the table. So these are the drugs. These are the drugs which come from nature. So now, please mute. Okay. Now, let us see what are aminocyclitols. As I told you this is an aglycol portion, which have cyclic structure in the name cyclic. Amino group, they have amino group and hydroxyl group and cyclic, six-membered ring structure, six-membered cyclic structure, having hydroxyl and amino group, having hydroxyl and amino group. So aminocyclitols are six-membered rings having hydroxyl group and amino group. Now, there are many aminocyclitols, but two forms of aminocyclitols are available in these marketed aminoglycosides. We also learned that aminoglycosides can also be called as aminocyclitol antibiotics because they consist of that. There are two prominent aminocyclitols. One is streptidine. This is streptidine. You can see it. These are the streptidine molecules. Streptidine. And one more is 2-deoxystreptamine. So let us learn first with the, for example, if there is one more hydroxyl group here, then it is called as streptamine. This is called as streptamine. So what is the name of this? You can see it. 2, 4, 5, 6 tetrahydroxy 1,2-diamino cyclohexane is called as streptamine. But our drugs doesn't consist of this ring. That's why we placed only 2-deoxystreptamine. 2-deoxy. There is no hydroxyl group at the second position. That's why the name is 2-deoxystreptamine. This aglycone portion is present in all aminoglycosides. Whereas streptidine, you can see it also has hydroxyl group, 4-hydroxyl group. Instead of amino group, there is guanidine group, guanidino group. This is guanidine. When just like methane, methyl, when you pronounce as a substituent, we tell as guanidino. Guanidino. 2 guanidino molecules are present. 2 guanidino molecules are present in streptidine. This aglycone portion is present in streptomycin, which is notable drug. All other drugs consist of this deoxystreptomine. That is the difference. You can classify under chemical classification like drugs consisting of streptidine, drugs consisting of 2-deoxystreptamine. Then now it's very easy. Streptomycin consists of streptidine. Remaining other drugs consist of 2-deoxystreptamine present in all other aminoglycosides. So these are aminocyclitol. Aminocyclitols are 6-membered ring having multi-hydroxyl group and amino group. Streptamine means what? I told you again, I'm explaining. Streptamine means there is also one more hydroxyl group. When you remove this hydroxyl group, then it is called as 2-deoxystreptamine, which is a glycone portion in all the aminoglycoside antibiotics. Now, whereas streptidine, which instead of amino group, there is a guanidino group or guanine group. Guanidino group. Now, here this is present in streptomycin. So these are the aminocyclitols. Now, so we studied all these. Now, see, what are important properties? Important properties. So as you see the structure, you people might have got some idea having that this drug consists of a hydroxyl group, amino group, and amino sugars. They are highly water-soluble drugs. Highly water-soluble drugs. Now, due to presence of these amino groups, we will learn one by one their properties. Due to presence of amino groups, they are basic in nature. They are basic in nature. So you can convert them into salt form. With acids like sulfates or chloride sulfates. Chlorides or sulfate salts, like for example, gentamicin sulfate, streptomycin chloride, neomycin sulfate. Though they are water soluble, we are making salt form. Salt form because they are basic in nature. So we try to observe. Without this salt form, they are not able to observe well. So that's why they have made in the form of salt form, because there are many amino groups in its structure. Formulations are water soluble and stable. And one more important thing we have seen in a tetracycline, the drugs gets epimerized, and dehydration also can occur. So they are unstable in water. Unstable in water. So now these drugs are stable even for months. So once if you reconstitute it, suppose if you get a drug in a liquid form, in powder form and reconstituted, it can stay for in refrigerator for months, and that's an advantage with these groups. Now one more important, see, stable in solution and more active in alkaline than acidic pH, highly polar basic drugs, because we know amino group, ionized during dissolution process, they get ionized. Distribution inside the cell is minimum because they are highly water soluble. So what happens is that they cannot cross the cell membrane. So wherever we need to administer there. So now see, penetration through blood-brain barrier is also minimal and least metabolized by hepatic enzymes. So most of these we have learned, when the drug is soluble in water, mostly without unchanged, without metabolism, the drugs can excrete out. Excretion is mainly renal, unchanged form, unchanged form through glomerular filtration. And one more important thing, these drugs, they try to concentrate at the nephron and inner ear. This leading to nephrotoxicity and ototoxicity. Ototoxicity. So these are the some of the properties which are very important in these drugs. So what we learned, though they have amino group and hydroxyl group, they are water soluble. And also we make them in the salt form because of amino groups, mostly because of salt forms due to sulfate groups and fluoride groups, like gentamicin sulfate, streptomycin hydrochloride, we can make them. They are very minimal absorption, minimum metabolism, excreted in unchanged form, excreted in unchanged form. So these are the things. So now that's what we told. And one more important thing is that not observed from GIT, metabolized by glycosidic cleavage. So whenever it comes by oral route or any, what happens? The glycosidic linkage is cleaved. When it cleaved, what happened? It becomes a simple aminocyclitol and sugars. And we can see the spectrum of activity. They are used to treat serious infections in gram-negative bacteria, such as TB, brucellosis, tularemia, and Escherichia. Then paramycin, especially paramycin, is very good for amoebic dysentery. Amoebic dysentery. It's a very good drug. We can see its importance of this drug. Now, one more important thing is that aminoglycosides exhibit synergism with beta-lactam antibiotics and vancomycins. Synergism is present, but what happens with aminoglycosides with beta-lactam antibiotic? There is physical incompatibility. Physical incompatibility. So this is one, if you give them in combination, you have activity, good activity, but what happens is that over a period of time, aminoglycosides is able to form complex with beta-lactam activity. So physical incompatibility is present. So they ask us not to mix the drugs, Most of these drugs are given by IV route of administration. So when you try to mix with normal saline, normal saline solution, usually we put injections in IV route, IV route of administration. So what happens? IV drip will be going on. So you try to inject both of these, then it causes problem. If you inject separately, there is no issue. So that is one advantage as well as disadvantage with these drugs. Now, streptomycin. We will discuss exclusively about streptomycin. So let us see. Now, this is the structure of streptomycin. What happens is that here you can see it. It has streptidine, as which we discussed. Streptidine is aminocyclitol, and it has two sugar molecules. That is streptose. This is streptose, and one more is N-methyl glucosamine. This is both of them are sugar molecules. Both of them are sugar molecule. This is 5-membered sugar molecule. This is a 6-membered sugar molecule. Both of them are sugars. How they are linked? You see, this is glycosidic linkage. This is also glycosidic linkage. Within the sugar molecule, there is a linkage. Though, as we learned, streptomycin has aminocyclitol streptidine, which has guanidino group. Guanidino group. Two guanidine groups are present. So you can make them as a salt form. You can make them as a salt form, like a hydrochloride or sulfate form. So streptomycin is available as streptomycin sulfate as well as streptomycin chloride. Chloride. So now, one more important thing is that, see, please. One more important thing is that both this streptose and N-methyl glucosamine is called as streptobiosamine. It's called as streptobiosamine. So you can tell that streptomycin consists of streptidine and streptomycin. Streptobiosamine. Clear? Please. Streptomycin consists of streptidine and streptobiosamine. Streptobiosamine is again consisting of streptose and N-methyl glucosamine. N-methyl glucosamine. Glucosamine. How these rings are linked? By glycosidic linkage. Glycosidic linkage. Now, the guanidino groups are strong base, and this is N-methyl glucosamine. We told glucosamine. Why? Because amino group is present. The N-methyl glucosamine, this base is a weak base. This amino group is weak base, whereas guanidino group are strong base. Strong base. Two bases are present. That is, one is two guanidino group, which are strong base, and N-methyl group, which is present in N-methyl glucosamine, is a weak basic in nature. Weak basic in nature. Any doubt, please? Okay. So this is about streptomycin. Now, let us see some of the important properties like SAR. Now, can we join again? It will finish. We will join again because it is going to close. Join again, please.